His talk is going to be on the benchmarking working group file system monitoring stuff. And as a guy who likes monitoring things, I'm going to be keen on hearing this. And I need to quote Andrew right now. You know, one of the things that he said to me and others, do not benchmark your system, monitor your system. And it's been very exciting. You know, we've been trying to do that, looking for signatures.
It's good.
We'll be calling you.
It's good.
Andrew Uselton, ladies and gentlemen.
Yay. So I'm here on behalf of the benchmarking working group, the monitoring subcommittee, I guess you could call it. Wanted to put out a little bit of information and mainly, I think, solicit for more information from you. So I guess I'll lead off with a couple of things for you to think about. I've got a very short slide deck here, so it's not going to take me very long to go through it. And so mostly I'm hoping we can actually get a little dialogue going. So if you can think for a minute or two while I'm talking about what it is that you do monitor on any Lustre systems you work with, and you know what, especially what the things that you find most valuable about that monitoring, and then also if you could get some information out of there, some telemetry that you aren't getting, that you don't know how to get, or you know how to get it, but it's just too much trouble. What is that? What would you like to be getting out of what information, what insights would you like to be getting out of your system that you're not getting? And then maybe, because we'll have plenty of time after I finish these slides, maybe we can go around and actually toss some ideas around. So this is the members of these are all benchmarking working group members who have taken an interest in the monitoring task, I guess you could call it. And the portfolio that we've sort of assigned ourselves is to just get an idea of what the parallel file system monitoring tools are that are out there, and what do they do and what should they be doing, and then maybe do a little compare and contrast at some point and get information up on the wiki. There's some information already there. We'd like to build up a large body of information there so that it could really be a nice resource that the sort of first go-to place when you start having questions about monitoring. So the basic problem that we're looking at is, when you instrument a file system, doesn't have to be a new file system, I'm not sure why the word new is in there. Any file system, once you decide you want to start instrumenting it, then, first of all, why would you bother to do that? And obviously, if you want to, detect monitoring health, basically, if you want to detect failures, that's certainly a strong motivation. You may also have contract compliance that you're interested in. So, is the file system actually doing what the people who sold it to you said it was going to do? And then, independent of all that, if it seems to be going, how would you know if it's going as well as it could be going? Well, you need to go in there and dig around and look. So then the question is, well, what kind of information do you collect? How often do you collect it? And then obviously what tools do you use to even try to get that information? So there are just a bazillion things you might conceive of trying to monitor. Certainly IOPS and read and write rate. You might also want to take a note in passing what's, for any particular component or for the system as a whole, what was the best it ever did? What did you, its maximum when when the wind was blowing in the right direction, what was the best number you actually got out of it? Things like, rebuild and verify statistics, device utilizations on the metadata server. You want to know what kind of ops and, for each individual metadata operation, what kind of statistics does it have, queue depths and latencies. You can do the same sort of things for all the RPCs. Then obviously you can aggregate metrics so that, instead of just saying what any particular LUN, what was its read-write rate, you can also say what was the file system as a whole doing. And, bazillion other things. This is not exhaustive by any means. And again, this is not an exhaustive list, but there are all sorts of tools out there. We'd love to hear about more. Certainly LMT has been around forever. Chroma is now IML in the IEEL package. Collect L is great. You know, there are all sorts of good things. If you haven't played around with Nick Cardo's MPI utilities, that's a really useful way of finding out if, you know, like a disk is, you know, if you've got a bazillion LUNs and one LUN is, you know, doing only 20% of what it should be doing, that might actually, you know, for a broadly striped file I/O, it might actually slow the whole thing down so that it's all slowed down to as slow as the slowest one. So you'd want to identify that, and Nick's got some really nice scripts for that. It would be nice if we had a really good, well thought out I/O model, you know, top to bottom model, so that we could then take all of this data and sort of put it into a context where we can understand that data better. I don't think anything like that, you know, really exists. I think that everybody has a sort of working model in their head, but I don't think anybody's formalized anything like that. So that'd be nice to have. And then certainly, you know, the committee is trying to, is soliciting word of any more metrics that we would like to try to track and any tools that we haven't already stumbled across. So that's basically what we wanted to say to you. Now, if you've given some thought to it, I'd like to hear from people. What do you think is the most valuable thing you do monitor? And if nobody raises their hand, I'm going to start calling names. Oh, come on, guys. All right, Larry, what do you guys monitor? What does NERSC think is the most important thing to keep an eye on?
Well, so I think in addition to all the things you mentioned, and this isn't Luster specific, I would really like to have a way to figure out how congestion on my fabrics is resulting in file system performance.
Thank you. So in addition to all the things you mentioned, I would really like to find a way to connect congestion issues on my fabrics with file system performance issues. And that's a problem that extends well beyond Luster and is connected with another desire of mine to be able to visualize congestion on my InfiniBand fabrics.
So does anybody have experience with trying to actually do that? Or tools? Are you familiar with any tools that might facilitate that? We've got somebody in the back.
Is it on?
Yeah.
Yes, we have experience doing that on a machine called Redstorm with a network problem. I think Ruth worked on it. Ruth? Didn't you work on that? Well, you could tell them about it. Aren't I nice?
There was a network sniffing utility they used on the switch itself. I don't know that's still available though. So it wasn't InfiniBand either. It was a gigabit Ethernet, and it showed that there was an imbalance in the distribution of traffic across LNet routers. So we worked from there with
traffic wasn't being routed fairly, that sort of idea?
Yeah, it would just pick a few at a time and use those routers. And so we worked with the Lester folks, and they varied their distribution algorithm so that it was more fairly distributed. I don't know if that'll help anybody now, though.
There is, you know, Mellanox claims that their UFM, their Unified Fabric Manager, will identify congestion and stuff. This is not an endorsement. I'm not saying it works. I've got it installed in my test bed, but I really haven't played with it enough to give it any good or bad points. But they claim it do it.
Has anybody else had experience with the Mellanox? Yeah.
So UFM product is decent. It's just that you need to pay for the license, right? But
I see. So it's a.
But then there is all kind of open tools that you can use to target any part of the fabric. You can collect all kind of transmit failures and, you know, how much data has been transmitted and how much of them is either discarded or is having errors.
Cool.
So all that information you may need to, you know, correlate back to how the Luster or clients are seeing the I/O performance, right? It's there, but somebody needs to put an overall umbrella, big arching umbrella that look at different metrics and then correlate and come up with some aggregated metric saying that is it working as expected or not.
That's cool. Do you've had experience with trying to do a little of this?
Yeah.
Great. Could you put together maybe an email, send it either to SARP or to me?
Okay.
Quick description of what you did, what the tools were.
Okay.
Maybe give us some insight into it. That'd be great.
Sure.
There's a comment here.
Hey, Andrew. Wow, that was really loud. Sorry, guys. There's a paper from Cug in 2010, I think, where I talked about a lot of the things that we do to monitor the file systems at ORNL. Something as simple as making sure that the health check file says healthy and reporting that back to Nagios so that there's an automated way to notify you. Recently, we've done some stuff with checking whether LNet messages are flowing properly. Look at Proxys LNet stats, and if you've got more than 30,000 outstanding messages for longer than 2 minutes or something like that, you say, we might have a problem. And that sort of goes to Larry's discussion about networking, but it's not, hey, look, there's an InfiniBand problem here. That would be a really interesting project to work on, I think.
Cool. Can you maybe put that in an email? I don't know if Cug would allow us to repost their stuff on our website, but we could at least maybe put a link to it or something.
It's public.
I mentioned yesterday in my talk, similar, we've been taking all of our InfiniBand errors, throwing those into Splunk. That allows us to correlate events, and we set up an alert, so if we were seeing too many transmit discards, right, we could actually flag it in our host monitoring stuff. Operators could see it. They could power cycle the switches, take some sort of action. It's a plug for Splunk. It's good at monitoring your data and taking actions, correlations, all that stuff.
Yeah, I'm really interested in your experience with Splunk. I haven't ever worked with it. Could you maybe post like an email message or something that says, what experience you had with it? If some of your tools, or even if you can share the tools, that'd be great. We'll definitely, put them on the website and point people to them.
Andrew, last week at OFED, there was a gentleman from a research group up in Canada. I'm checking through my notes to see if I can find. He had an intern student that was also going through, they used Splunk, they wrote some scripts to help order the data into it, and pretty much all of the log files that they had. And you can set the level of verbosity and all that stuff. But they had some really amazingly nice visualizations that were able to emerge from this grad student, intern student that was using Splunk. So I'm going through my notes now, see if I can find that what it was. But they had visualizations that showed some unexpected things that were going on in the fabric, where parts of the fabric were like being avoided. They had like bare spots. And the graphs were actually sort of even pretty, but you could actually see where the clumping and the gaps were, where you were, perhaps getting the congestion, and other parts of the fabric were growing underutilized. And, that would give them a reason to go then and look a little further. But I heard Splunk referred to in the OFED conference last week 3 times for doing data mining on the logs.
That's cool. Do we have more ideas for what to monitor, as well as what's not being monitored that you'd like to see?
So just to triplicate actually Splunk using for IBMon, we at Lenel are doing the same thing, and we're actually pulling the performance logs from the console logs on our InfiniBand fabrics and passing that off to Splunk so that we have both the error logs and things of that nature, but also performance logs that are going in there. We haven't done the next really big step, which is correlating those performance numbers to any luster errors that we experience, but now that we've got all the data, it's just a matter of freeing ourselves up to do that.
When you say performance numbers, you're talking about like read bytes, write bytes?
Correct.
Stuffing the proc stats?
Correct.
That's cool.
But that's not just luster. We do that with all our systems, all the Ethernet switches. We use Splunk at, a large scale.
And what's your experience with, once you've, dumped 500 megabytes of log lines into Splunk and you say, okay, now I want to go ask it a question, is it pretty responsive?
I'll let him answer.
We were hearing yes.
It depends, yes.
Cool, that's
Yeah,
good.
it's-
That
it's
speaks
not
well of
bad.
Splunk.
Yeah, I mean, it's a matter of organizing your data as well, right? So some forethought in how you organize the data going into Splunk helps you out a lot whenever you go to actually do your searches and things of that nature, and it can expedite your search strings whenever you start
Cool.
to really
If you
correlate.
could put together, just a little case study, a few paragraphs in an email, send it to us. I think that would make a big difference to people who are sort of still, who don't know anything and are only starting to look. If they could read a few things like what you've said and what Mark's talked about, I think it'd be really valuable to people.
The guys were saying that the troubleshooting value alone in not having to go log in to 10 or 15 different machines and grep for certain, strings.
Yeah, absolutely.
You could go to the one place, you could go to the one aggregate of this massive set of logs that would otherwise just be this big tangle. And again, instead of having to go literally log into half a dozen to a dozen machines, they were able to go, know that they had this nice smooth flow of all this stuff going in, and they could go to the one spot and say, all right, when did you have your problem? What machine were you on? What nodes did you have? And they could, zero in on what their user issue was.
Cool.
So I think, in addition to having tools to look at the logs, I think there's a rethink needed for some of the LNet routing configs. A lot of people just use one flat pool and don't really look at things like peer credits, interface credits enough to understand how LNet applies on top of their fabric. Not to ping Cug again, but there was a couple of papers out of Cray last year from Cug about how they designed their LNet networks to do fault isolation from the start. So when they get a congestion problem, it's isolated to a particular subnet off of LNet, and they know, oh, it's within these 3 OSTs connected to this one leaf switch through these set of 4 router nodes. And immediately the problem is isolated down to a set of hardware that is much easier to diagnose, and then you can actually get in there and understand doing stack comparisons. I think they use a lot of pandas and linear regressions. So if you run the same benchmark across 30 router pools, you can do a correlation of the stat differences from Proxys LNet. And usually you'll get a set of OSSs or router nodes that jump out, and they'll be a standard deviation or more out of whack with the other nodes, and it's a little more obvious. But it takes setting up your LNet network from the start to give you that data that's differentiated.
That's cool. If you could drop an email with the reference to, the Cug papers you're talking about, that'd be very useful.
Sure. Yes.
More ideas? Yes, we've got down here again.
It's finding the information, let's say, a new user to the luster, what are the metrics that, is there guidelines that, okay, these are the things that we should be looking and following, and if these numbers are X number, these are the thresholds, and if it is beyond this, you have a problem. Do we have that kind of knowledge base somewhere?
I think that's a very interesting thing for the monitoring group and the benchmarking working group in general to try to develop that kind of understanding. Yeah, I think we're still very much at the very beginning, but I'm sure that SARP would agree that that's definitely where we want to go.
Something I wanted to mention, so in 189, the BRW stats proc file had a lot of useful information for just troubleshooting the I/O size from down to disk.
Yeah, I love that.
And I know there were some issues with 2.4 or Lister 2 with that that being accurate. I don't know if it is, but I just want to communicate that is a useful piece of information. It's something we use, but something on top of that, a tool to be able to visualize that on a larger scale is what we really need to look at, not specifically BRW stats, but like in Proxys, LNet, look at average queue lengths, these type of metrics to monitor across all systems.
Those are great ideas, and I think, if it never got, if all you did was to post an email to the benchmarking working group saying, here's my list, I'd like to get visualizations of BRW stats, Q lengths, that I think at least would really be a place marker, and then somebody come along and actually develop it. That'd be great. Drop us an email.
That would be great, thank you. Yep.
And then you can go write it. You did just volunteer, I heard that. Have you got more ideas? Cool, this has been very useful, thank you.